Hello, this is a continuation on subsidies, but a little more focus on graphing, diagramming, understanding the graphing, as well as a few calculations. So let's jump right into it. So first things first, just a quick review of what subsidies are. So these are amounts of money the government will give a firm in order to increase their output. There's a variety of reasons why. One could be, for example, the good is a merit good, like education or healthcare. I'm trying to lower the price. Another example would be trying to encourage growth of a nascent industry, a new industry like solar, wind, etc. Other reasons would be to guarantee supply of products that are necessary, so things like basic agricultural staples, things like energy sources like coal. That's why you see most governments subsidizing energy, usually in the form of oil in some shape or form. Other reasons would include protecting employment, as well as enabling producers to compete with overseas companies. So you'll see, South Korea help Kia, Japan will help Toyota, Honda, while the U.S. will help Ford, Chevrolet, and so forth. So with that said, let's get right into it. So subsidies, the actual subsidy itself is indicated with this space between the supply without a subsidy and supply with a subsidy. So that gap right here, you can see this from 2, and there's no text there, but we could presume if it is a €50, that this is 3. So it's very messy here. It is 3. This is 350 over here. There we go. Now, let's jump into consumer expenditures. So consumer expenditure, the original point would be where the original supply is before we had the subsidies. So where these points meet right here, this is the equilibrium at €2.75 and 6,500 cartons. So the original consumer expenditure would be this area right here of E, F, I, J, L. So we could do a quick calculation there. All we've got to do is multiply 275 times 6,500. So let me just grab the calculator here. 6,500 times 2.75. That equals 17,875. So that is what the consumers used to pay. Now, with the introduction of subsidies, both the price has gone down and the amount purchased has gone up. So we are now purchasing 8,000 at this cheaper price of 2. So this little purple area, which would encompass I, K, M, L, J, this area is showing you the new consumer expenditure, how much consumers are spending. Now you'll notice 2 things. One is the price is cheaper and they're able to buy more. So because of this, even though they're buying 8,000, it's only at €2 each. So I could do that in my head. 8 times 2 is 6, so 16, so 16,000 euro. So you'll notice that the amount the consumers spend has gone down by 1,875. Not only that, but they're purchasing more. They used to purchase 6,500, now 8,000. So all in all, consumers are pretty happy about this change. Now, moving away from consumers, let's focus on the producer side of things. So the producers, their original revenue is also at this point right here, right, where the original supply meets the original demand. However, they are not making the money right here where the consumers are paying. Their new source of revenue, let's use yellow, no, let's use blue, is this entire area. So what's happened is not only are they getting this, little IJKML, right, from the consumer side, but they are also getting this entire rectangle above, the BCEDFG. What the heck is this money? This money is all subsidies, right? The government is taking care of that bit of money. So they are making an equilibrium here, which means they are selling at 350 euros, so quite a bit per unit, and they are selling 8,000, so that doesn't change. So 350 times 8,000, that comes out to 28,000 in producer revenue with subsidy, right? Without subsidy, it was 17,875. So we're talking a change of, they make over 10,000 more now. I think 10,125, an increase. So on the producer side as well, people are happy. We give them a bigger smile there. So big take home here is both the producers and the consumers are happy. Now, one final point to keep in mind, though, is this money, right? This Euro 50, right? This whole area here. This is not necessarily free, right? We know that this money comes from somewhere, right? It comes from taxes. It comes from things like property tax, income tax. It comes from VATs, right? It comes from money people pay to use the airports. All that money goes to the government, and then they decide, right, what to subsidize. In this case, milk. So in that regard, again, it's not really free, right? There is a whole mechanism of who to subsidize, who not to subsidize. It's very political, and it connects to the things we've talked about with CLASP, evaluations, and things like why governments will subsidize one item but not the other. So again, although everyone is happy with subsidies, keep in mind that money does come from somewhere, right? There's no such thing as a free lunch. So the second part I want to focus on is the consumer surplus and producer surplus. So let's take a look at that. So first, we need to identify the original consumer and producer surplus. To do that, we have to identify where the original equilibrium was, which is right here, right, where S1 meets D1, so before the subsidy. And then we look at the area above this price point of 275. This is the consumer surplus. And the area below is the producer surplus. Now, what do these areas exactly indicate? We'll start with consumer. So consumer surplus, this area of A and B, indicates people are willing to pay €5, but if they actually only pay 275, this extra bit of happiness, right, or utility, this is showing through the consumer surplus. Or this person here is willing to pay €4, but when they pay 275, this space here, this distance between the actual price and how much they're willing to pay, again, consumer surplus. Similar sense, this E area and I area, you have producers who are maybe willing to sell it at €1, but when they do sell it at 275, this extra bit is also utility, right? It's showing the producer surplus. Or this user, or this producer right here is willing to sell at 2, but they end up selling at 275. So this space as well is utility. So the E and I, this is producer surplus. Now, how does it change? So we'll start with the consumer side. So the consumers, as we know from the graph a second ago, they're paying down here, right? They're paying less money, they're buying more. So now, key data there is they're paying €2, right? And they're paying 8,000. So if we now look at these letters, you'll notice that E, which was not part of it earlier, right? Because it was 275, and F and G, these three areas have now joined the consumer surplus for milk because of this lower price and greater quantity. So consumer surplus has increased. Now, in a similar note, if we focus on the producer side, for the producers, they are making more money, right? So for them, it's not down here at 2, but they are selling it at 350, right? This line over here. Right? They're selling at a higher price and they're selling more. So now it goes beyond just the E and the I. We also have B and C, right? These 2 points, which used to be not in the producer surplus because they weren't selling at 350, right? They're selling at 275, and these people were not necessarily happy, right, to sell it at these prices. Now these people are part of the producer surplus, so we've added the area of B and C. So in summary, we have an increase of both producer and consumer surplus. Now, let's calculate them. So we don't need to do both because it's kind of similar, the method. So we're just going to calculate the change of consumer surplus. So with consumers, if you remember a second ago, it used to be just the A and B, right, this area. And now it includes this E, F, G, H. So you might see a question on a test like, what is the change, right? How much more consumer surplus? So in that case, the goal would be to calculate E, F, and G. So to do that, we would first just find the rectangle of E, F, G, and H, even though H isn't part of it. So to calculate that, I'd look for the distance between 2 and 2.75, which is 0.75. I would then calculate the distance between here and here, so 0 and 8. So that's 8,000. So that's just now simple multiple question. 8,000 times 0.75. Some people can probably do that in their head. 3/4 of 8,000 is 6,000. So we know this whole box is 6,000. Now that's not what we want though, right? We want this whole box, but we want to isolate H and subtract it. So to find H, we just have to find what is this little square here. So that would be, again, 0.75 for the height. And then for the width, this space here, it'd just be 6,500 to 8,000. So that's 1,500. So now we just multiply those two. 0.75 times 1,500. Might need a calculator for that one, just in case. 1,500 times 0.75, 1125. And that's not the answer we want, right? Because we know this whole box is 1125. We just want half of it to isolate H. So 50% of that, so let's just multiply by 0.5, is 562.5. So we're almost there. We know that this entire box is 6,000, and we know that we just need to subtract 562.5 from it. So let's put these two together over here. 6,000 for this entire rectangle. We're going to subtract the 562.5 from it. I'm going to use a calculator to be safe, 562.5, and that should come out to 5,437. See if that's correct here. Calculating the new 6,500. So it should come out to 5. Just double checking the math here. So the whole, this big rectangle is 0.75 times 8,000. So that's 6,000. And then we're subtracting half of this, which is 1,500 times 0.75, 1125. And then half of it is 5,625. Yeah, that's right. So we have 5,437.5. Now, let's move on to the last point here, which is dead weight loss. So for dead weight loss, we have to first be able to identify it. That is this area right here, this triangle. And what this triangle is indicating is over allocation, right? As in with these subsidies, it's the opposite of indirect tax. We have too much of this product, and that's represented with the D and the H. So the way we'd calculate the D and the H is quite simple. We'd first calculate the full rectangle. So to get the full rectangle here, all we have to do is calculate the width and the length. So when it comes to width, it's the distance between 6,500 and 8,000, so that's 1,500. And then when it comes to this length here, or height, we're talking 2 to 350. So we're talking 150. So 150 times 1,500. So I think some people can do that in their head, right? Times 1.5. So half of that is 750. So basically just add 750 to that, which comes out to 2250. So 2250 is what this whole area is, 2250. But that's not what we want, right? What we want is 50% of that, or 0.5. So we would just multiply it by 0.5. That would bring us to 1125. And 1125 would be the welfare loss, or the dead weight loss, right? Half of this, so the D and the H. So that equals D and H. So there you have it. Those are some of the major calculations you should know. Things like the change in consumer expenditure, right? It starts from there. Now it's here. Things like how the producer revenue is here and now up here. Things like recognizing that this space on the top here, this is the subsidy. Recognizing things like this DH area, this is dead weight loss because of over allocation. And I think, yeah, those are pretty much the main points to remember. And that's it for today. Thank you.